Now again, uh, in this video we will establish the equivalence of Kelvin Planck statement and Clausius statement. We will take a device which violates Clausius statement and combine it with a device which does not violate Kelvin Planck statement, and finally we will combine this together to show that the device violates Kelvin Planck statement also. So here you have a high temperature reservoir at TH and low temperature reservoir at TL, and you can see a refrigerator which takes in QL and supplies QL to the high temperature reservoir, and then it takes in heat QL. uh, you can see that this refrigerator violates Clausius statement because it is no external work is supplied to this refrigerator. And then you have the heat engine which takes in heat QL uh, and releases QH, and the net work output is, you can see that it is QL minus QH. So this heat engine, you can see that it does not violate Kelvin Planck statement. So you have a refrigerator which violates Kelvin Clausius statement and a heat engine which just does not violate Kelvin Planck statement. Okay. So let us combine these together. Okay. If you combine these together, we will show that this violates Kelvin Planck statement also. So you have the low temperature reservoir. So you take in QL minus QHC. If you combine these two devices, okay, that means you are supplying QH here and QL here. So it takes in QL minus QH. It takes in QL minus QH. You can see that, for a high temperature reservoir, this QL can be connected to this heat engine. That means you don't need a high temperature reservoir here. You can you can supply this QL to here. Okay, so for a refrigerator, uh, so if you combine these two, uh, when you combine these two, it will form a heat engine. You can see that this forms a heat engine. So there is no exchange with high temperature reservoir, that is QL, and it takes in QL, right? And it produces a net work, that is QL minus QH. So if you look at this heat engine, this heat engine clearly violates Kelvin Planck statement. Why? Because you can see that you have removed this high temperature reservoir. It exchanges heat with only one reservoir, low temperature reservoir, that is it produces takes in heat QL minus QH, and then produces work W net, that is QL minus QH. That means you are combining these two. So you can see that it takes in QL and supplies this. So net work heat exchange with the low temperature reservoir is QL minus QH. So since it supplies QL to this high temperature reservoir, this can be supplied here, that is QL. Okay, so you don't need a high temperature reservoir. So this can be reduced to a heat engine which takes in heat QL minus QH and produces net work, that is QL minus QH.